So 3.3 is solving systems by elimination. Leah on the shelf above you. Red. Yep. If we are solving systems by elimination, the coefficients have to be the same, or they have to be similar, like a negative and a positive. If they are not the same, then we have to change them so that they are the same. So for 92, so for 92, x has the same or similar coefficient. They're both 1 and negative 1. So we can eliminate these by adding the two equations together. If we add these two together, we have negative x plus x, which is 0. 9y plus negative 3y, which is 6y. And 11 plus 1, which is 12. From there, we can solve for y by dividing. Savannah, Preston, make sure you're paying attention, writing this down. So y equals 2. Then we can use this, put it back in either of the equations we are given to find our x. Does not matter which one. I'm going to put it into this one. So we have x minus 3 times 2 equals 1. And we can solve for x. X minus 6 equals 1. If I add 6 to both sides, we get 7. And we can write this as an ordered pair.
Could you do it with the negative x plus 9? Or do you have to do the bottom equation?
Say that one more time.
Do you have to do the bottom equation or can you do the top equation?
Yeah, we can put it into either or, it doesn't matter. I just put it into the bottom because x was almost by itself. Or basically by itself. Other questions on that one? Rashad, if you need another one, there's some on the shelf. If you need another one, there's some on the shelf.
This is 7.
We're going to do one more of these, unless you have other questions on this page. Have a good weekend. I'll come back to that. For 96, these do not have anything in common, any common coefficients, so we need to either make both of the x's the same, or for our y's, we just need to make this a 5. So that would be easier than changing both. I'm going to just multiply this first one by 5. So this would give us negative 35x plus 5y equals negative 120. Now we have the same coefficient for y, so we can subtract these two to eliminate the y's. If we are subtracting, this becomes negative 4 minus a negative, so these two become a plus. So negative 4 plus 35 is 31. 5 minus 5 becomes 0. 4 minus the negative would be 4 plus 120, which is 124. And then if we divide both sides by 31, we get 4. So now you have 3 options where you want to put this x first, second, or third. Does not matter where you choose. I'm going to put this into this first equation without the 5 because y is by itself is
So when I solve, I don't have to like get rid of the number in front of 5. So negative 7 times 4 plus y equals negative 24. This would become negative 28. And then we can add 28 to both sides. So y is 4. So our ordered pair would be 4, 4.
Do we have any questions on that? Are there any others on this page you want to see or go over or have questions about?
You can number 98.
98. For this one, we need to rearrange things because we can't just start this unless they're all lined up.
Easiest way to do that would be to rearrange this first one so it looks like the second one.
But it doesn't matter, you could rearrange the second one to look like the first.
So I'm going to move 9y over and add 11 over. This becomes negative 9y plus 8x equals 11.
Now the process is the same. We have to make either y's or x's the same.
This is 3.3. Does not matter. I'm going to get rid of x's because. So that means these both need to be the same. 40. So if I multiply these by 4 and these by 5,
The x's would be the same. You could also just multiply whatever they are to each other, so 10 and 8. That would also work.
so this would become negative 40y plus 40x equals 80. And negative 45y plus 40x equals 55.
Then, now that we have the same common coefficient, we can subtract these two to eliminate.
So negative 40 minus negative 45 would be adding 45, which is 5. 80 minus 55 is 25, question mark?
Yes.
And then we could divide both sides by that.
Now you have 4 choices you can put y back into. Either of the original equations or either of the 2 new. It does not matter.
I'm going to put it into this one. Negative 11 plus 8 times, this is x equals 9x. Negative 11 plus 8x equals 45. Add 11 both sides. 6. And divide both sides by 8.
No matter which equation you choose, you should get 7. So our ordered pair would be 7, 5. The ordered pair if it's one solution. If it's no solution or infinitely many, you won't get, you'll get like this. And you'll be able to tell, because you'll have zero, some number equals another number, which would be no solution, or some number equals the same number. 5 equals 5. That would be infinitely many. Any other questions we want to go over or see or had a question about on this page? So for 95, our y values are the same. So we can eliminate these by subtracting these two equations together. If they have the same, subtract. If they're different, add. 5 minus a negative would be positive 12x. Negative y minus a negative doesn't cancel. 19 minus negative 29 would be adding. 48. I don't know if that's accurate. Whoops. So divide both sides by 12, we get 4. And then put 4 back into one of your equations, does not matter which one. And solve for y. This would give us 20 minus y equals 19. Subtract 20 on both sides. And then divide both sides by negative 1. So this would become 4. On the next page, this is the last objective in systems. Your word problems. Find important things we're going to do 101. So in this case, you also have to remember, if it says with a tailwind, the wind is pushing the plane, so that's adding. On the return trip, it's going back into the same wind, so the plane no longer has that tailwind to push it, so we would subtract the wind. And we are looking for the speed of the wind and the speed of the plane. So the first thing you should do after that is define your variables. Doesn't matter what they are, x and y, w and p, whatever they are. Tell me what these represent, what we don't know. So this would be the speed of the wind and the speed of the plane. After we define our variables, we need to write our equations. So with the tailwind, we're adding the wind to the plane speed, so W or P plus W. Back into the same wind, we are not having that plus anymore, so it would be P minus W. Then we need to solve this, so you have different options. You can solve by graphing, by substitution, by elimination. It also doesn't matter which one you choose to solve. Let's say I want to get rid of P's first. I could subtract these two equations together. So that would give me 0 P's. This would give me 2W and 104 minus 66. I don't know what that is. 38.
And divide both sides by 2 so that W is 19 kilometers per hour.
Then you would put that number back in to find P.
If I do P minus 19 equals 66, and I can add 19 to both sides, P equals,
I don't remember what that number is. 85. So define your variables, set up your equations, solve for one of your variables, put that back in, solve for the other, if you're doing elimination. If you do get something like this, make sure that your wind speed is lower than your plane speed. It would make sense for the wind to be faster than the plane. If this is a boat and stream situation, same thing, boat should be faster than the stream speed. Do we have any questions on this one? Yes.
So for elimination, are you able to choose which variable?
Yes. Which variable? Yes, to eliminate. As long as they have the same or similar coefficient. It could have done either one. Are there any others on this page we would like to see or go over? If not, we're going to move on. So now we're in Unit 4, our inequalities. So we're just going to do a couple of these. For 106, we need to combine the terms if we have any. So negative 5 minus 7 would give us negative 12. And then we need to get B by itself. So move 12 to the other side by adding. 8 is less than or equal to negative 8B. And then divide both sides by negative 8. So negative 1 is less than or equal to B, or B is greater than or equal to negative 1. Oh no, I should have switched this up. If we're dividing by a negative, make sure you change the sign because I forgot. So it should be B is less than or equal to negative 1. That would be a closed circle when you go to graph it at negative 1 going to the left. Do we have any questions on that one? The last one we're going to do is 111. Same process, we need to get x by itself, but first we need to distribute on both sides. So we have negative 16x plus 16 is greater than 24 minus 8x. And then we can pick and choose what we want to move. So I want to move 8x over to the left by adding, and move 16 over to the right by subtracting. You can do the opposite.
this would give us negative 8x is greater than 8. And then divide both sides by negative 8. Our sign could change directions. So this is now x is less than negative 1. That would be an open circle at negative 1 going to the left.
Do we have any questions on that one? Are there any others on this page we want to go over or have questions about?
Yeah.
120, 112. So for 112, we need to distribute. So this would give us negative 6 minus 7k minus 7 is less than negative 5 minus 15k. Combine all of your like terms if you have any. Here, this would be negative 7 and negative 6. And then after you have done that, start to move things. So I'm going to move 15k to the left. And add 13 to the right. So this would be 8k is less than 8. I don't know why these are all 8. That is weird. And divide both sides by 8. K is less than 1, so there will be an open circle at 1, 1, 0. Other questions on this page? On the next page, compound inequalities is something we did not too long ago, so hopefully you remember this somewhat. We're going to do an and an or, unless you want to see others. So for 113, this is an and inequality, so we have to solve everything together. So we would need to get rid of 4 by subtracting it everywhere. So this would become negative 5 is less than x, which is less than or equal to 8. And then we could graph this. This would be an open circle at negative 5, a closed circle at 8, with a line in between. Do we have any questions on that? Number 117. This is an or inequality. You have to solve these separately. So for this one on the left, we need to get rid of 7 by subtracting. So 10x is less than negative 50. Divide both sides by 10. So x is less than negative 5. Then I'm going to go ahead and graph that one now. It's going to be an open circle
open circle at -5 going to the left. On the other side, we would need to add 7 to both sides. So we have 7x is greater than or equal to 14. Divide both sides by 7. So that x is greater than or equal to 2. That would be a closed circle at 2 going to the right. And you need to have an or in between them.
Do we have any questions on that one? Are there any others on this page you want to see or go over? Next objective is your graphing linear inequalities. So this is similar to just graphing lines. So on 124, we would need to convert this, get it in a slope-intercept form first. So subtract 5x on both sides. We have 4y is greater than negative 5x minus 20. And divide everything by 4. So y is now greater than negative 5 over 4x minus 5. And we would graph this like normal, start at negative 5. Our slope is negative 5 over 4, so I have to go up 5, to the left 4. This would be a dashed line because it doesn't have an equal to underneath. And this would be shaded below. I'm sorry, above. Because it's greater than. If you're not sure which way is above or below, draw an arrow up and down at the y-intercept. Above would be up, below would be down. So above would be this. Do we have any questions on that? Are there any others on this page we want to see or go over? On the next page, last objective for inequalities, your systems of inequalities. So there's 2. We're going to do 131 at the bottom. We will need to solve both of these. I'm going to do that at the same time. So this would be negative y is greater than negative 4x minus 2. And y is less than negative x minus 2. The first one we would still need to get y by itself, so divide everything by negative 1. So y is now less than positive 4x plus 2. and then we can graph both of these.
This one would start at 2 and go up towards the right one, down toward the left one. This would be a dashed line shaded below. So again, below would be underneath the y-intercept, so all of this. The other one, our y is less than negative x minus 3, would also be dashed and shaded below. So this would start at negative 3. Our slope is negative 1, so I can go up 1, left 1, as many times as possible. Down 1, right 1, as many times as possible. It's dashed, but I'm just going to leave it as dotted because I have, it would look too messy to do that. And below would be underneath the y-intercept. So the overlapping shaded area would be this small triangle here.
So when you have systems of inequalities, make sure you're either using two different colors, two different directions of shading, maybe shade one lightly, shade the other one darkly, something like that. Do we have any questions on this? Are there any others on this page we want to go over? The next page is your variations. So this first section is your direct variation. You have to remember a couple things about that. One, it should be in this format, y equals kx. That should be on your page already. So it's going to be some line that goes through 0, 0. For these, we're looking for which ones look like this format, y equals kx. For this first one, x is in the denominator, so that would not be 1. The one underneath that, it looks like this format, but it has this y-intercept that's not 0, so that would not be 1. For this next one, this looks like this format, it has the y-intercept, but the y-intercept is 0, so that would be 1. The one underneath that has a y-intercept that is not 0, so that would not be 1. This one we can rewrite as y equals 2 over 2x. So this is in that format. And then same thing for this one. We can rewrite this as 1 over 2x. So this is 1. You could also go into your calculator, put in y equals these equations, see which ones are lines that go through 0, 0. Questions on that first part? Number 5, there are two different ways to go about solving this. I'm just going to show you the easier of the two. So for this, we have 6630 in interest, 5100 in per bank account. The interest in this is like our y, or is our y. Very directly with the amount deposited, that's like our x. To set up how to solve this, we're going to set up a proportion, y over x.
So we're going to do 6630 over 5100 equals, we're looking for how much you would receive in interest for the same amount deposited. So we're looking for our y value and we know our x value.
To solve this, we're going to cross multiply.
y equals 132,600.
Then if we divide both sides by
100, y is 26.
do we have any questions on that one? Before we go on to the next objective, are there any questions in here that we want to see or go over or have questions about?
For number 6, you're now looking at inverse variation,
Where y equals k over x. So we're looking to see which of these would be inverses. If it looks like that format where x is in the denominator, it's going to be an inverse. You could also graph these. If you graph them and it looks like this weird curve thing, it's called a hyperbola. But if it looks like that, that would also be an inverse. So for this first one, x is not in the denominator, that is not 1. The one underneath that, x is in the denominator, that would be 1. For this one, if you solve for y, you have to divide both sides by x. So y equals 5 over x, so that would be 1. Y equals negative 2 over x, x is in the denominator again, so again, that would be 1. The last two, x is not in the denominator. X isn't. So these would not be inverses. On the next page, this is still part of inverse variation, but we're going to do number 10. For number 10, just like with the direct, you can set this up as an equation. So the volume V is like our Y, varies inversely as the pressure X is like our, pressure P, that's like our X. If we weren't given equations, we would multiply y and x together. But in this case, we're going to multiply v and p together. So if the pressure is 20 pounds per square inch and the volume is 13, we're going to multiply those two together. And set that equal to, we're looking for the volume v when the pressure is 10. So it's like a proportion, but not. It's just an equation. So this would give us 260 equals 10v. And divide both sides by 10 to solve for v. So 26 cubic feet VRV. have any questions on that one? Before we move on to the last objective in variation, do we have any questions in this section, 7 through 11, or want to see any of those? So we're just going to do a few in this last objective. 13 and 15 are just setting up equations. If b varies inversely, we are dividing. If it varies directly, we are multiplying. So in this case, we are dividing f. So b equals, there's always going to be some k in there somewhere. So b equals k is really what's dividing, or f is dividing by. And then directly as s, we are multiplying by s. Or we can write it so that k and s are next to each other. Either of those would be fine. Do we have any questions on that one? For 15, z varies jointly is like directly, but there's more variables. So we're going to be multiplying. So c equals, we need our k, and then we're multiplying b and g. And inversely as d, so we're dividing b. Do we have any questions on that one? For 19, we know the cost c varies jointly, so we're going to be multiplying all of these variables together. So if we set up our original equation, we know c equals k times our width and length, so w and l. Then they give us a bunch of numbers. We're going to put all those numbers in and see what we need to solve for. So we know the net cost $14.40. We are not given our value of k, but we know the width is 12 and the length is 20. So we can solve for k. This would be 240k. Divide both sides by 240. And we get 6. Then the last part of this, we are looking for the cost of the debt. But we now know our k, we know our width and length, so we can put all of those in. So we're looking for c, k is 6, our width is 107, and our length is 20. Oh, I don't know why 20 was from another one. Not wrong. This was before. That looks right. So this would be $25.68. Do we have any questions on that one? Are there any other questions in this section that we want to see or go over? We are now in Unit 6, our factoring unit. So hopefully some of this is still fresh in your memory because we did it not too long ago. 6.1 is our factoring by DCF. Remember that we are looking for what does everything have in common, something we can divide out of everything. For each of these, I could divide out 2 would work, that would be the highest. 4 would also work, but again, that would not be the highest. I could divide each of these by 8. But because this first term is negative, I'm going to make this negative 8. Then we're also looking for amount of variables they have in common. If I said 6, well, this one doesn't have 6, so that wouldn't work. If I said 4, well, this one doesn't have 4, so that wouldn't work. 3 wouldn't work, 2 wouldn't work, only 1 is what they have in common. So I can divide each of these terms by negative 8b. But because we're factoring, we don't want it to actually disappear. We're dividing it out into the front. So if I divided negative 16b to the 6 by negative 8b, that would be a positive 2. B to the 6 over b would be b to the 5th. We took 1 out. Negative 48b to the 4th divided by negative 8b would be positive 6b to the 3rd. And then these last 2 would be positive 6. It should be 3, not 6. There we go. There's nothing else for us to factor on the inside. All of these numbers are prime. Or I can't take 2 out of these 2, 3 out of these 2. Out of anything else, so there's nothing else for us to do. Questions on that one? For 134, same thing. Look for what these each have in common. I can divide 2 out of all of these. And I can divide a certain amount of b's, and it would have to be the lowest amount here. So I can take 3 b's out of each of these. If I divide out 2b to the 3rd, this would give me 2b squared plus 7b minus 7. The inside doesn't have anything else we can divide out, so that would be our final answer. Do we have any questions on that one? For the D's? What number do you think we should pull out? That's a better question. Can I take 5 D's out of 4? To all of them. Are there any other questions on this page we want to see or go over? Next page. We are factoring by grouping now. Something we did when we factored when A wasn't 1. So factoring by grouping only works if we have 4 terms. If we have 4 terms, we're looking at the first 2. What do those 2 have in common? I can divide both of these by 5 and x squared. So if we divide out 5x squared out of these, just the first 2, we have x plus 4. Then of the last 2, we're looking for what do these 2 have in common. We can divide out a 1, but because this is negative, this would become negative 1. So this would be x plus 4 when we divide that out again. Then we take the numbers outside of the parentheses, and we have 5x squared minus 1 as one of our factors, and x plus 4 as the second. Ian, you can grab your phone. No. Do we have any questions on that one? We're going to do one more of these. For 148. Same thing, look for what these first two have in common. That would be 12 and n squared. If we divide out 12 n squared, we have n minus 5. Of the second two, we can divide both of these by negative 15. And if we divide that out, we have n minus 5. So then our factors, we have 12n squared minus 15. And n minus 5. For the 12n squared minus 15, we can divide that again, because I can divide each of these by 3. So if I divide out of 3, we have 4n squared minus 5, and then our n minus 5. Which means we really could have divided each of these by 3 at the beginning. But it doesn't matter when, as long as you do it eventually. Questions on that one? Are there any others on this page you want to see or go over? On the next page, we're going to do a few of these. Factoring by difference of squares, or using difference of squares. This isn't something you can there's a formula for it, you kind of just have to know this. If everything is a perfect square and you are subtracting, you're going to have two factors. You're looking for what times what would give you 4, which is 2. It has to be the same. What times what would give you n squared? And that would be n and n. And what times what would give you 9? Which would be 3 and 3. And then in between those, put a plus and a minus. Yeah, so if I were to distribute this back out, the middle terms would cancel and I would end up with this. Maddie, you can grab your phone. Questions on that one? For 160, this is the same thing. You will still have two factors. But, sorry, my brain. These are still perfect squares, but this is no longer squared, it's some even term. So this would still be 2, but when you have an even term that's not 2, cut this number in half, so this would be a squared. And then 5 and 5. And plus and minus. Do we have any questions on this one? Yeah. Say that one more time. 162, yes. There's one other one we're going to do that's similar, so that may change your mind, but I'll split them up. For 163, same thing. You're going to have two factors. Still looking for what times what would give you 25 and 1, so that would be 5, 1.
this is an even power, so again, you can just cut that in half, so that would be b to the third, and then plus x.
Daniel, did you still want to see 162?
Yeah. So this one is similar to 163. You're going to have two factors. We would need to find what times what would give us 1, which is 1 and 1. What times what would give us 16, which is 4 and 4. And then cut this exponent in half. So x to the third and x to the third, and the plus and x.
Any others on this page you want to see or go over?
Next page. Now we are factoring when a equals 1. So for this first one, we are looking for two numbers that multiply to be 15, but add to be -8.
So we would need to think of our factors of 15. There's 1 and 15, 3 and 5. And we have to think how could we add those together to get 8. Well, 3 and 5 would give us 8. But they both need to be negative in order to get -8. So we have -5 and -3. In this type of trinomial, you can go directly into your factors. Whatever the variable is will be your variable first in both. And then -5 and -3. Do we have any questions on that one? On 170 on the same page, this has a number before the square term, but look and see if you can take out a GCF because that might change things. For this one, we can provide 3 out of each of these. So this would be n squared plus 2n plus 1. Then we're looking for two numbers that multiply to be 1 and add to be 2. The only two numbers that multiply to be 1 are 1 and itself. So this would be 3 times n plus 1 and n plus 1. Or you can write n plus 1 squared. Either or. Questions on that one? Are there any others on this page we want to see or go over? Last factoring objective, when a does not equal 1. So for this first one, we would need to first see if there's a GCF. If there's not, I can't divide 3 or 13 or 10 by any of these numbers. So we are then going to multiply 3 and 10 to get 30. And we're looking for two numbers that multiply to be 30, but add to be 13. We think about our factors of 30. We have 1 and 30, 2 and 15, 3 and 10. If I add 3 and 10, that will work. So then we can rewrite this into 4 terms. The first and the last term are going to stay the same.
squared, take the two numbers you found, put them in with the variable x, or whatever your variable is.
So plus 3x, plus 10x, plus 10. Now we have 4 terms, and we can go back and do our grouping. These two I can take out or divide out a 3 and an x, which would leave us with x plus 1. The second two we could divide out a 10, which would leave us with x plus 1 again. And then our final factor would be 3x plus 10 and x plus 1. Do we have any questions on that one? We're going to do one more of these. For 177, if we think about the factors of these numbers, so like 21, 1, 21, 3, and 7, we can see if any of these can be divided by any of those numbers. I don't think 21 is a factor. 7's not, but 3 works. I can divide each of these by 3. So that would leave me with 7n squared plus 48n minus 7. And then the process is the same as before. Multiply 7 and negative 7. We're looking for two numbers that multiply to be negative 49, but add to be positive 48. 49 and 1 would work if 1 is negative. So we could rewrite this into 4 terms. 7n squared plus 49n minus n minus 7. And now we're back to factoring by grouping. These first two, I can divide out 7 and n. If I do that, we have n plus 7 left. Of these last two, we can divide out a 1, but this is negative, so negative 1. And that will leave us with n plus 7. So our final factors would be 3 times 7n minus 1 and n plus 7. Do we have any questions on that one? Are there any others on this page we want to see or go over? We are now in Unit 7, our quadratic stuff. For 183, we will need to solve this using our square roots, but first we're just going to solve this, get x squared by itself. So add 5 to both sides. So we have 7x squared equals 700. divide both sides by 7.
So x squared equals 100.
And then we can take the square root of
100. Or of both sides. We have x equals plus or minus 10.
Anytime you do this, you need to have both answers, positive and negative version.
And then write your final answer in curly brackets. So you can write it like this, plus or minus 10. Or you can write it as separate, negative 10 and positive 10.
Do we have any questions on that one?
For 184, same process. Add 7 to both sides.
Divide both sides by 4. I forgot to move my calculator over.
If you aren't sure if this is a perfect square or not, take the square root of this into your calculator.
So second x squared would give us our square root. This is not a perfect square. So I would just leave it as the square root of 71. So in our answers, we would write them in curly brackets, either like this, plus or minus the square root of 71, or you can write them separately. But if it's not a perfect square, leave it as the square root of whatever. Do you have any questions on that one? For 187, process is the same, but I'm dividing by a negative. So this is going to give me a negative. You could see if this would work in your calculator, but it's going to give you an error message. So anytime you have a negative underneath the square root, and here we would say that's negative. Questions on that one? This last one, if we add 9 to both sides, we have n squared equals 0. If I take the square root of both sides, the square root of 0 is just 0. So this would just be 0 inside the solution set, or inside the curly brackets. Do we have any questions on that one? Say it again. 90 divided by 95 is negative 18. Are there any other problems on this page we want to see or go over? We're going to do the next 2 pages, but the second page won't take that long. This one will take a little bit long, but for this one, this is your graphing quadratics and then finding your solutions. So here we have to find our axis of symmetry where this would, the middle of this would be, using x equals negative 8 over 2a. So x equals negative 8 over 2 times our a value, which is 1. So x equals negative 4. And then we're going to use our calculator. So if you're still following along, grab a calculator if you didn't already. And we're going to go into y equals and type this in. If you type this in and then go into your table, second graph, and find where x is negative 4, you're going to start at that point and then go as far as you can. I think our graph only goes up to 2. So we can do negative 6, 0, negative 5, negative 3, negative 1, negative 4. And then once you have one side, the other side is going to be a mirror. So at negative 3, this should be a negative 3, negative 2, this should be a 0. And connect these. So that would be the graphing aspect of it. The solutions part of it is where does this, if it does, cross the x-axis. Remember that answer, you can have 2 solutions, 1 solution, or none. So here it would cross it at negative 6 and negative 2, so you would write those as ordered pairs, negative 6, 0, and negative 2, 0. Do we have any questions on that one? Are there any others on this page we want to see or go over? So this next page will be the last one we do today. This is just you're given a graph, state the solutions. So for this one, this does not cross your x-axis at all, so this would be no solution. This one touches your x-axis once, so that would be 1 solution at negative 4, 0. And then 201 crosses your x-axis twice at the points 0, 0, and 2, 0. You can have 1, none, or not infinite limiting, that's something else. 1, none, or 2. Do we have any questions on this page? Daniel. Are there any others on this page you want to see? Or go over? So on Tuesday, we are going to go over, there are 2 last topics we need to talk about before you take your final, and then we'll continue final exam review. And that's absolute value equations and absolute value inequalities. So we're going to do that on Tuesday, start the absolute value equations, and then continue with final exam review. We only have not that many more objectives left. So there's 1 more in Unit 7, the 5 in Unit 8. There aren't any Unit 9 because those were all review, and then the 2 in Unit 10, the absolute value stuff. So we'll be doing that next week, as well as your final is next Friday. So make sure you are practicing this stuff on your own time as well as in class. Come see me with any questions you have on these. The answer key is on Canvas. I will be here in the morning. You can come see me. We can go through problems, or Tuesday afternoon. As well as if you have not finished the tests or need to still retake, come see me in the morning. Wednesday? That's wrong. Thursday morning will be the last day I'm accepting late work, missing tests, retakes, anything like that. If your tests, retakes aren't done by then, I'm grading them as is. So keep that in mind.